Hi all, welcome to my channel. So this is the first video on in my 15 video series on Java concurrency in a new way called creation of a thread. So in this video, I'm basically cover you about creating a thread between how can we create a thread. There are two ways to create a thread, either extending a thread versus runnable. I'll talk more about in depth now and also after explaining the concept, I'll basically implement a code in a live programming. So how can we basically create a thread? There are two ways to create a thread. One is basically extending a class, and second one is basically implementing a runnable interface. So these are the two ways to create a thread. We'll see basically the best practices of between like when to use extending a thread or when to use basically implementing a runnable interface. But before that, let's implement both and let's understand how the thread execution is happening like. So in the create thread package, so basically I have created two classes called using extends thread and using implements runnable. So now basically I'll try with basically extends thread. So for example, if you go with extends, right? So we have a class called thread, which is basically extending. And you can simply write a main method. So once you extend the thread, right, what we can do, we can basically override the properties, right? So in order to start a thread, we should basically invoke the run method. So which means like we need to override the run method. So it's basically overridden. So here we need to basically execute whatever process we want to be run, whatever code block we want to be run in a thread. Okay. And also, if you like to know the current thread name, right? You can just simply basically mention the thread.current thread.get name. It will basically print that okay, this is the thread name currently running. Like so, in your main method, first you basically create a object for the using extends thread class. Once you create an object, how can you basically start a thread? We have a method called start method. This will basically internally invoke the run method. So let's, you can also ask like, okay, I can directly do the run method, right? If you directly do this run method, it's basically like a normal method, right? Here we are basically overriding a method and we are directly using this overridden method. So which means it won't basically create a thread. So it won't basically start a thread. So we need to, so you can also simply run the program. So here you will get to know that it is just it's just running this one, like thread is running and you won't get any information like. So if you see, I'm basically executed the directly run method. It does not execute anything. It just basically executing the like a normal program. So every Java class is a kind of a thread, right? We have a main thread is there. So that's why it shows the name called main thread, thread name as a main. So, and also our IntelliJ also giving suggestion that you might need to replace with basically start in order to create a new thread. So just try to replace a start and try to execute again. Now let's see what will be the thread name like. So here see, along with the main method, you have basically also invoked created a new thread called thread 0. So what you can do, you can just simply, so if you do this one, right? So you will basically clearly understand that we have a main thread is there. And once the thread is created, we have a separate thread is basically running this particular job like. So you will see two print statements. So because if you see main thread is running, after main thread, you're creating an object and basically we asked the start method to execute this run like. So the start method basically creates a new thread and it will start running like whatever we mentioned here. So this is the task we are basically running. So under this task, we have a thread name, which is basically called thread 0. This is how we basically uses the extends thread using the class thread in order to create a thread and run the thread. Now let's see how can we do with the help of runnable interface. It's also simply we can implement the runnable interface. This is the this is the function interface, which is it has only one public method called run method. So you can basically implement a method called run. So start thread in runnable. Thread dot current thread dot get name. So let's create a main method. So this is basically a runnable, right? So what you can do basically, you can now let's create an object for using the implements runnable. And what will happen if you directly do the run method, right? So here, what exactly will happen? Nothing will happen. Just like normal thread only. Like it's basically invoke the main method. Nothing will happen. Like if you see, start thread is basically runnable main thread. So which means like you cannot directly basically invoke the run method, like just how we saw in the using extends, right? So now what is the what is the like how can we do? Because if you see the extends thread, we have basically in the thread package. So what's for example, if you see the thread class, right? In a thread class, we have basically multiple methods are there. We have start method is there. We have run method is there. We have like there are like n number of methods are there. So we easily call the start method. Now, if you see for the runnable, right? Runnable doesn't have any method apart from run, right? So what we should do? So runnable is a kind of a we basically decoupled the thread starting versus the our actual task. So we are basically asking a thread to start to basically execute this task in a multi-threading environment. So for that, first you need to create a thread. This is how basically you create a thread. So once you create a thread, here you basically pass the this using the template runnable. So which means you are basically making this particular class as a thread. Now, once thread is created, you can simply start a thread dot simply start method. So now all the properties will be there. So once you can just simply click on run. Here, if you see, this is the main thread just normally working, just a normal function execution. This is here we basically sending this particular object into the thread and asking to start a thread. So this is how we basically decoupled the task from the. This is how we basically implements runnable will work. Now the question is basically when to use when, right? What is the best practices like? Now let's see basically what are the best practices. Prefer basically implementing runnable for most use cases. So for example, if you are basically already working, right? If you see any of your company's code, then majority of code base is basically presented with the implements runnable over basically extending thread. There are like a lot of advantages offered by using the implements runnable than extending a thread. And also the main reason is basically it promotes a clear separation of a thread task from the thread object itself. So thread, as we see, thread task is different. So we have we have implemented the run method. And after overriding the run method, so there we basically return whatever task we want, right? That's a thread task that is completely separated from the thread object itself. So we created a thread object and we basically send that class object inside the thread, and we then asking the thread to start a job, to start a task. So that's how basically we using the implementing runnable. If you're using the extending thread, right? When you can use extending thread, if you want to modify the thread, if you want to modify or enhance the behavior of thread class. So basically you want to override all the properties of thread, like for example, start, shutdown, maybe interrupt, all the thread lifecycle thread, which you're going to see in the next video. But whenever you want to change the behavior of internals of thread itself, then extending a thread will basically gives you override everything. Like, so that's where basically in order to control the complete thread management, beyond just executing a task, that's where you basically use the extending a thread. Otherwise, always go with the basically implementing a runnable. And also when it comes to resource sharing, if your threads need to share resource, right? For example, basically there are like multiple, there are a single object you can pass into the multiple threads, right? So which means like there sharing a resource will be happening. So which means as you decouple the basically the thread task from thread itself, you can basically call the same object multiple times in a multiple threads. So that's where you can basically use the runnable or callable is a suitable choice when it comes to resource sharing. Like, and when it comes to concurrency utils, right? As we said, like we have an executive framework that is a most powerful framework where we basically submit a task and we basically execute a task. So there it's basically taking a task, which means it's taking a runnable or callable task, not like extending thread classes. Like, so so as basically executive framework itself using the runnable one to take a thread, to take a task. So for basically enhancing the scalability and performance in going forward. So before, okay, anyway, let's see with some of the real world scenarios. I'll give you this scenario. Let me know like what is the way, how can we go? How can we proceed? You can pause the video and you can think whether you want to proceed with the runnable or you want to proceed with basically extending a thread class. You're developing a web server that can handle multiple client requests concurrently. So basically each request is processed independently and you want to implement this process in a parallel to improve throughput. Just think of like you're developing a web server that can handle multiple client requests concurrently. So which means you have an object and you want to submit that object right into a thread and start a thread. And basically each request is processing independently. Like there may be multiple objects are coming, right? And just you need to invoke those all the objects in a threaded environment so that your main program won't wait to till this complete. So it will keep on taking the request. So in this scenario one, what is the best strategy we can do? You can think of, as already given the answer, decoupling the object creation of client request with the basically task submission. That's where we basically use the implements runnable. So we'll basically implement, there is no issue. Yeah, let's implement and go with the different scenario. For example, let's see, I'm basically implementing this web server request. Let's say I have given name called client request uh, handler, right? So this is the client request handler. I'm basically implementing the runnable. Once implementing the runnable, I basically implements the only run method. So here you can basically so client request. So what? So what is the basic thing in the client request? Let's say ID. So we don't need to go into very in details, in detail of everything. Just basically go with the ID and just getter. What do you call getter? Now ID is prepared. Now basically you have this client request, right? Now basically you are basically processing a request, client request. And in the main method, simply create an object client. Let's see some of the advanced concept. I'll basically visit in the future, but just understand like how basically executor service will work like. So here I'm using the executor service. Here I'm basically I'm basically creating a fixed thread pool of 10 thread pools. So which means like I'm creating a 10 threads in my server. So it can basically parallelize operation up to 10 requests. I can parallelize operation. So here what you can do, you can simply do so basically what we generally do, here if you see, we are submitting a runnable task here. That's where we basically implement the runnable. Just submit a task. What you can do, simply you can what we can do, we just need to create an object, right? And once you create an object, uh, let's create an let's create a dependency. Um, yeah. So what exactly we are doing? We are basically creating an object inside a thread, right? Which means it won't wait for the this particular process to be completed. So it will basically will happen in the different thread, and basically our main server will keep on accepting the request. It won't wait for the client request one to be completed. Then only client request two will be served, right? So we can just once we're done with the operation, we can simply shut down. So we can see executing the program like. So here, okay, dot get ID. Here, see, so basically all the operations are started, right? So our client thread is basically not waited till the processing request one is completed. Then only processing request two is taken. So it is not waiting, right? It is basically hitting everything in a single go. Like, so our client is now capable of more parallel processing and accepts the more request. And this is basically better user experience, right? Than comparing. Then having a one request and waiting for the request to get to get the response back, and then only second request will be served. So which means up to 10 requests I'm basically parallelizing like. You can also simulate, you can also you can also simulate with the help of thread sleep. Let's say you are basically sleeping 5 milliseconds. Yeah, if you execute this program, here what will happen, all the processors are completed, but it's still in processing like our cursor is not completed, right? Now cursor is completed like. Or for better simulation, you can basically do this one also. um, Process complete, right? So process complete of yeah, if you run the program now, so all the 10 threads will basically fire at single time, but I have it's a very long process. It has waited for 5 seconds. So now once the five seconds are done internally, it fetching from DB, doing some lot more process. So once everything was completed, we are getting the process complete as so each process is getting completed asynchronously. So it doesn't mean that the process one should be complete, then only two should complete, then only three should complete, right? This is how basically we are leveraging the runnable interface by parallelizing the all client requests, like. So which means for this scenario, our best suitable is basically implementing the runnable. Now let's see second scenario. Let's assume like you are creating a specialized monitoring tool that needs to be performed background monitoring of system resources. For example, how much CPU, memory usage, everything at regular intervals. And this tool needs to be highly responsive and might require overriding some of the thread methods. Here, if you see, I'm also giving the hint that I just don't want to execute a thread. I want to override the existing thread methods, right? Required overriding some of the thread methods for detailing control. So, okay, whenever I'm monitoring during thread.start, okay, when I'm starting a thread, I am started the monitoring of so and so application. When I'm basically something happened, okay, this particular monitoring application got breaked because of thread interruption, which means like I'm basically overriding the each method inside a thread. I'm basically customizing the whole thread behavior itself. So which means like here, what exactly it is expecting, you are modifying the existing thread behavior only, right? That's where you basically extends the thread more than implements a runnable interface. Let's see that example also. For example, let's give a name called system monitor. And let's here we are trying to extend thread, extends thread. Once you extend thread, obviously you'll basically override the run method. So here, let's perform some life cycle. For example, I'm basically starting a thread, then it will run sometime, then I'm basically shutdowning a thread. So here, to simulate that one, let's take a Boolean variable. Initially running is false. Now I'm basically keeping while running. Monitoring system resources. So, okay, I have basically started running this one. So while running, right, I can also basically put it in a thread.sleep. Let's say I'm basically keeping 1 second. What we will cancel interrupt exception. Once we get the interrupt exception, we can make it as basically running equals to false. So initially, let's keep running is true. Then we can basically false, and you can basically override the start method also. You have the flexibility, right? So here, what you can do, you can basically perform starting monitoring. So you are basically overriding the start method and adding some extra functionality, changing the thread behavior, right? You can perform get name, and you can simply start. And now let's basically, you want to shut down a thread, right? Let's do shutdown. So here, how can you shut down? You want to interrupt the thread, then only you can do shutdown, right? So you make running equals to false, and you can simply call the thread dot interrupt. You can call this particular thread, just interrupt this one, like this dot interrupt. So you are basically interrupting the current thread. So that's where it basically coming out from loop whenever you call this shutdown method. So here. and you're basically calling the get just to simulate shutting down. Now let's go with the main function. In the main function, let's say, let's create a object, what system monitor. Let's start a thread. Once you start a thread, basically, just thread dot sleep, let's say 1000 milliseconds. Once you basically interrupted, right? Here you can basically do this, what you call shutdown system monitor dot shutdown. So this will forcefully interrupt the thread and it'll come out from that loop, like while loop. So now let's run now basically you can also do here, or you can basically do here as well. Like, so this will basically, it will wait for one minute. Sorry, I think 1 second. It will try to shut down. Once we shut down, in between whatever pending threads are there, right? Those will be forcefully interrupted. So if you see, like, starting monitoring thread 0, monitoring system resources, and we basically interrupted the thread from this infinite while loop, and we basically thread becomes shut down after 1 second, right? So this is how basically we are basically changing the properties of existing thread itself. That's where we basically use the extends thread over implements runnable. Like, this is the second scenario. Likewise, I have given another 2 scenarios. I'll give you the homework. Maybe you guys can identify and tell me, like, what is a suitable one for this scenario 3 and scenario 4. You guys share the answer in the description. I will basically review and reply. Like, so the scenario 3 is basically, imagine you're developing a stock market analysis tool that needs to be processed stream of data. That is, data is coming from multiple sources concurrently. Each data stream might require different handling logic, but they all need to be run in a parallel to ensure real-time analysis. So here I give a condition that each data stream might require different handling logic, but they all need to run in parallel. So here the keywords are basically needs to run in process stream of data from multiple sources and running in parallel to ensure real-time analysis. So which means, like, just think of, like, what is the best one and how can you implement that one also. I'll basically review and respond for all your comments. And the finally fourth scenario is basically, consider a scenario where you're developing a custom logging framework that needs to perform some complex log management tasks in the background, such as periodically flush log entries to the disk, rotating log files at a specific interface, and sending critical log entries to the monitoring system. Here, what I am asking, a log needs to be perform some log management task in the background to periodically flush the log entries to the disk. After a certain time, maybe flushing the log entries to the disk, rotating log files to specific intervals, and sending critical log entries to the monitoring system. So here, whenever we invoking a thread in the logging, right? So here it's asking us to do some operations while processing a thread, while processing that particular thread job. So just let me know your answers from scenario 3 and scenario 4. I hope you got difference between what is basically extending a thread and basically implementing a runnable. So please do answer those scenario 1, scenario 3 and scenario 4 questions, whether we should use implements runnable or basically extend thread. I hope you got the complete information. And sorry for the pause of the previous video. I didn't notice it. I'll make sure it won't happen in the next time. So in our next video, we'll basically discuss about thread lifecycle, and also what all different states of a thread between new, runnable, blocking, waiting, and time waiting, and terminated, and all the different thread methods. And also I'll basically cover the importance of each state and how transition occurs, and examples of method causing state transitions. Everything in detail, like today videos only. through programmatically only. Like, so we soon meet in the next video. If you like the video, please share and subscribe to your friends. And yeah, that is the support you can give me. Like, thank you. Like, bye bye.